I just shot you guys a Desmos link. I'm going to share my screen so that the recording can see it, basically.
Oh, no,
so
that makes
basically,
sense.
to fill you in, Ty, you on these where you where it has you write something, we just discuss it as a group and move on. But sometimes it needs you to like input values, and then we just all input some values because then it makes a graph, stuff like that.
Like
So
for adults.
at the start of this assignment, so we're doing rational functions, and instead of just showing you what they are, we're going to have a pizza party. So we're having a pizza party. Food, right? We're having a pizza party, a pretend one at my house because we are in a pandemic and we can't actually have pizza parties. So we're getting 15 slices, 15 pizzas that we're cutting into 8 slices each. So first off, who can tell me how many slices we have?
Not me. I mean, I could, but it would take me like 10 minutes. And we don't
No,
have that kind
okay. Ty just volunteered. Ty, what's 8 times 10?
80.
And what's 8 times 5?
40.
And so what's 8 times 15? What's 80 plus 40? Yes, thank you. Perfect. So we have 120 slices of pizza. So let's, instead of saying, what do you think should be the most amount of guests I should invite to the party? Or I guess, sure, throw one out there. What's the most amount of guests we should invite to a party with 120 slices of pizza?
Is this just how many people I enjoy having around? Because I would say like 2.
Okay, so
I would do 0 because I want to eat all the pizza myself.
I just don't like humans.
0. So, but you can invite 0 people to the party. Okay, Mark?
Well, you have to at least invite yourself.
Because you have to at least invite yourself. Because you have to at least invite yourself, which is important to the math part of this whole thing. So the least you can invite is 1, which is yourself. So let's all go to slide 2.
To get a pizza is 1.
So let's all go to slide 2. For this to work, we're going to need everyone to at least put 3 in.
Okay.
So Mark, you threw out 1 party goer. How many pizza slices each would you get if you were the 1 party goer?
All of them.
Which is
120.
So put in on yours 1 and 120. Ty, you said 2.
Yeah.
How many slices do you get with 2?
You get 60.
60. So that's actually you and 1 other person. So put in a 2 and 60. If you invited 2 people, it'd be 3. We get 40. I'm going to throw in 3 and 40. Zach, how many people do you want to invite to the party?
I'll invite 3,000.
3,000. Okay, so how many slices each do you get? Just use a calculator.
1,000.
No, let's do it. This is fine. We're gonna math this.
120 divided by 3,000.
Mm-hmm. So 0.04 slices each. 4% of a slice. So, but put 3,000 and 0.04 into yours. Okay, Zach?
Yes.
Okay,
I invited 40 people and they each get 3.
Perfect. Do that.
But I would actually just hide in the corner because I don't want to talk to that many humans.
Well, I'm an extrovert, and even I find it hard to talk to 40 humans at one time. And I find it even harder to find 40 humans who want to listen to me unless they're forced to, such as students.
I'm like, we have to listen to you.
You have to, though. That's the key.
Now
you understand why I'm in this whole gig. Okay, I have a normal, average, run-of-the-mill social life here. I'm going to invite 9 people for 10 at my party, 12 each. So I'm going to put that in on mine. What's some other? Zach, you decided 3,000 was actually a little bit more than the amount of contacts you had on your phone.
Yeah.
Give me another suggestion.
How about 4?
4, which is how many each?
30.
30. Okay. And then I'm having a social function for an event that has 75 people, and I just way messed up and only have 120 slices of pizza. So I'm having 75 people, and they get 0.0625 slices each, or 0.625. Okay. Has everyone filled it out? Has everyone got 3 in theirs?
Yeah.
Okay.
I'm inviting Google people.
Oh, Mark. Yes. How many?
So-
Mark, you said Google. That's going to be really hard for the math. Unless you can,
1.2e minus 98.
you can put that in if you can put that in on Desmos.
Absolutely not. Wait, so
Okay.
what do so if the chart to the left, put the people you suggest attend the party. Me, my
No.
dog.
No. So the number. So Mark.
Me. My
Mark.
dog.
So how many people do you want at your party? You said 1 first, right? So you'd put 1 at party goer and 120 on pizza slices each.
Okay, so then what do I do
Well-
for food?
What do you want?
What would they eat?
But you actually decide you want people at your party, Mark.
Yeah,
So how
my
many do you
dog,
want to invite?
2. I just like my
You
dog.
invite 2.
Invite my dog.
You invite your dog. So there's going to be 2 people total. And how many
Mark, your
slices are
dog
you
should
each going
not
to
eat
get?
that much pizza.
I'm gonna give him 119 slices of meat. No, I'm gonna give him 5. Wait, how do I do this? What?
Wait, no, it's if you divide it equally, not just how many you give to each
60.
person.
Okay, there
So
we go.
2 and
Yeah.
then 60. And then if you decide to have a big party, but not a Google-sized party, how many people are you going to invite, Mark? You can pick any number.
10.
10. And since I already did 10, we'll have you do 11 since you invited 10. And so I'm going to use a calculator. 11 divided by 120. If you invite
I thought it
11,
was 120 divided by 11.
oh, it is 120 divided by 11.
10.9090909091.
So just do 10.9. So write 11 on the left and then 10.9 on the right.
So they just get, it's basically 11.
Okay, so now let's go to slide 3. So in algebra class this week, my teacher was talking about graphing lines. It's what we do. I told my mom if we graph all the possibilities, it will make a line. She asked why. To make a straight line. I said because the number of guests, as the number of guests increases, the number of slices decreases. So it will make a line with, wait, don't go ahead. Don't break Desmos. So it'll make a line with a negative slope. Am I correct in saying that this is going to be a line?
Yes. Also, Mark, your camera is frozen.
I'm aware of that. It does this literally every 10 seconds.
Yeah, it's not.
So we got a
not
yes.
Do it freeze your camera.
Does
Yeah.
everyone think this is going to make a line?
No program
Yes.
to turn your phone
Yes. So everyone click yes.
I clicked yes.
Okay. You don't
Reggie,
need
you
to.
clicked no.
Oh my gosh. So why do we think this is going to be a line? Because Desmos suggested it?
Because that's how things work.
Aha. But not always.
But that's how this works.
So let's all. Well, why do you think it's going to be a line, Zach and Mark?
Well,
Because it's equal.
Wait, no. Because if you can't have 0 guests, which would be a stop, and you can't have negative, so it'd be like, would that be a
You
ray
can.
downwards or something? Or would that be a ray instead and not a line? Because you can't like have negative guests and you can't do.
It's a line segment.
Yeah, no, it won't be a line segment. It'll be a ray. A line segment is from 2 points. A ray just goes from a point.
I guess.
Yeah, I think it's gonna be a ray.
Okay.
I'm tweeting for Zachary.
I love these answers. Let's go to the next slide as a class. Boom. Okay, so here we go. We have over here. Oh, I didn't know it was only going to cut it off. So it cut off our bigger ones.
It's a slope.
But so what's off the screen? We did 3,000 guests. 3,000 guests is at 0.04. Right?
Mm-hmm.
So what do we think our little slopey line looks like?
It looks like a curved, a parabola. Is that a thing?
Mm-hmm.
Yeah.
Can we ever have 0 slices each? Mark, what happened when you invited a Google amount of people to your party, which for folks who don't know is 1 with
I'm aware.
100 zeros?
zeros.
Right.
Well, you could say that happened.
You got this tiny, tiny little number, right?
I have a gift. That's what happened.
Was
That's
it
what happened to
bigger or
Desmos.
smaller than 0?
I mean, it was like 120 divided by group roll 1.2 e minus 98.
Mm-hmm. But it's bigger than 0, right? Just by
Yeah.
the tiniest of little amounts.
Well, if you had infinite, it would be infinitely small, which is as close to 0 as you can get.
But is it bigger than 0?
No, yes,
Yes, it is.
it has to be.
And can you have 0 guests?
No, I mean you
No.
can. You can if you leave the house and just
But
put the
remember what
pizza.
our rule was. That you can't.
I would order the pizza and then leave the house for a week.
But then technically it's not a party.
How do you know? I can have a personless party. Or maybe I ordered it for a bunch of dogs and they're not people.
Fair.
My
but
dog just got up as you said that. He was like, I'm sorry, what?
I'm pretty
I am
sure your dog still isn't a
disgusted.
person, Mark.
I am disgusted. Okay, let's go to slide 5. Okay,
Did I break it?
so instead of, I don't even know if they're going to graph it. I don't think so. Which, if
You
they're not, this is
can give
boring
people
anyways.
negative
Yeah.
pizza slices.
Okay, so no, you cannot.
Then how come
So-
it showed up negative 92?
So we established that our little graphy looks like this, right? Roughly.
We can't see that, Reggie.
Oh, I have to unshare.
No, we can see it, but you just were in a bad spot.
Can we see it?
Yeah.
Okay, so we established our graph looks like that. Let's, as a math lab, let's as a laboratory, let's try
I
and
have to go in
guess
2 minutes.
what would the equation of this line be?
I don't
Y
know.
equals, like, would it be y equals x squared?
Sure.
No.
Oh, I don't know.
Would it be y equals
Y minus 2.
y minus 2? Maybe. Any other guesses?
Could be. Y equals potato. Just draw a circle.
Okay.
Y
Well,
equals my computer.
if we're at y equals potato, we're ready to move on from the guessing phase.
Y equals potato.
Just post.
We're ready to move on from
I
the-
Google.
Boom. Okay. Oh, get out of here, Desmos. So go to the next slide.
I have to go, Reggie.
Ty, thanks for joining Math Lab. Enjoy the community meeting.
Thank you. Bye. See you guys
Bye.
on Monday.
So, Mark, Zach, that's who we got left, right?
Why are there 2 Zacharies?
I don't know. Oh, is it the Zach that shows up in the back of Zach? So, do you guys think this graph ever intersects the x-axis?
Maybe. I don't know.
Maybe. That's fair. Let's go to slide 7. Oh, we didn't come up with one. We had y equals y minus 2. So it's not going to show us one. Okay. Can you guys think of any other real life situations that would fit this model and create a graph that looks like this, that can never be 0? Let's think about here. Let's do this a different way, guys. Mark, Zach,
There's 2 of me.
let's try and write. Let's think about the equation that we would write for the pizza party we just did, right? Okay. So y equals the slices per person. Okay. And x equals the number of guests, right?
Mm-hmm.
So what would the equation look like to the y equals equation look like for that pizza party if we're trying to find the slices per person out of the number of guests? I lose you guys? Mark's in the matrix. Zach's playing egg splatters.
Zachary, did you see that
Help me out,
extremely
guys. We're
satanic
almost
thing
to
I
the
sent
done.
you? We are almost to the done.
We're almost to the done. Help me out, guys.
English.
So, if y is my slices per person, and x is my number of guests, what would my equation be to figure out the slices per person from the number of guests? If I have 10 guests, how do I figure out how many slices they each get?
Well, you divide the number of like the
Slices,
number of slices by the
which
number
is
of
how many?
120 divided by
10.
10, 12.
You
Now,
give them all
if I
one
want to,
slice.
if I instead of want to find out how many for 10, I want to find out an equation for any amount of guests, and I replace x with number of guests, where would I put it?
So
120,
divided by 10 is
or if x is my number of guests instead of 10,
120 over x.
like that. So that's the equation for the formula we just did. Y equals 120 over x. Okay? So if you're trying to find an equation that creates that curved line that never touches 0, right, for either axis, can I divide by 0? No. X can never be 0 if x is on the bottom here. And if I can't divide by 0, can y ever equal 0? No. So equations that are in the format of y equals 1 over x are what these are rational functions. And these are going to look like these that we drew, where it's this curved line that can never touch the axes. Okay? So let's really quickly, we don't need to finish this other Desmos activity, but let's start it, okay? And then we'll be done with Math Labs. I'm going to send you guys a link right now. And we're going to go to it. It should be Introduction to Rational Functions. I'm going to present my screen. You guys there? Zach, Mark? This won't take too long. So we've already started this. Make a sketch of the graph y equals 1 over x. We already started to, right? We know what it looks like. It makes that little open mouth, right? Never touches the axes. Something like that I drew on my screen. Boom. Okay, let's go to slide 2. So here is the graph of y equals 1 over x. Notice there's actually 2 of the mouths, right? So what do we think the y value is when x equals 0? Is it 0, infinity, 1, or not possible?
I think it's not possible.
It's correct. It's not possible. You can't divide by 0. So let's go next.
It won't be a number.
So when they say give the domain and range of the function, they mean the possible x and y values. What are the possible x values? X can be greater than 0, right?
Be infinite, pretty much.
But it can't, well, almost. It can be greater than 0, but it can't be greater than or equal to 0, right? It can be less than 0, but it can't be less than or equal to 0. Right? So that's what it would look like. You can see on my screen. X is greater than 0. Oh, I did it backwards. And less than 0. But it can't be equal to 0. So, can you guys go to slide 4? We're almost done. This will just take a sec. It's the end of the school year, I know. So you guys see slide 4, Mark, Zach? Mark's frozen.
Oh yeah, I frequently get frozen because of the dumb.
Mark's frozen. I think we lost Zach. You there, Zach?
Here.
You're here. Okay.
Okay,
You guys,
so a section of my screen is illuminated and the rest is empty.
no worries. Okay, so an asymptote. You guys see this word up here? An asymptote is a line that a graph approaches but never intersects. So if you look at this graph here, where would you guys, if I were to draw the asymptotes, there's two, where would you guys draw them? Tell me where to do it.
At like that point right between the two.
Right here. And but there's a line, right? There's two lines you can imagine, right?
Yeah.
One line, can you cut the music for a sec, bud? Just till we're done. So one line would be here at x equals -2, right? And where would the other line be?
At 0, right?
No, up here, right? We're at y equals 4,
Yeah.
right? So notice this is the equation to y equals 1 over x plus 2 plus 4, right? And then notice where our asymptotes are. Ah, what was that?
That was a squeal.
Ow. Okay. So we have the equation y equals 1 over x plus 2 plus 4. And then we have the asymptotes at x equals -2 and y equals 4. So let's go to slide 5. If you guys can get through this, we'll call it for Math Lab for the day, okay? So we need to match these 4 graphs to these 4 equations. So instead of having you do it on your own, I'm just going to have you guys tell me what to do. Okay? So we'll take this first one. Y equals 1 over x plus 5. Which of these 4 graphs would be to the equation y equals 1 over x plus 5?
Not really sure. Oh, it'd be the one in your bottom right. No, not the bottom right. Sorry, the
Good
one.
guess.
Top right.
Top right, exactly, because the addition after the expression 1 over x moves the y value. So that one matches there. So then we have 1 over x minus 5 with the -5 underneath the division symbol. So which one would that be?
Bottom left.
This one?
Bottom right. Sorry.
Yes, bottom right, exactly. And then we have 2 left here. So we've got y equals 1 over x minus 2 plus 3 and 1 over x plus 3 minus 2. So which of these would go to which? Mark, you still there?
Yeah.
So Mark, remember
Where's
this addition and subtraction outside of the division expression moves the y value, and inside moves the x value. So which of these graphs would match up to which of these equations?
Well, I don't even know because I just finally found this stupid Desmos thing because I somehow closed the tab.
Oh, no worries. We're on slide 5.
Oh, here it is.
You can do it on my screen, though. Take a look at my screen. So we have these two equations. Y equals 1 over x minus 2 plus 3. And y equals 1 over x plus 3 minus 2. And we're trying to match them to these graphs.
I think this thing has problems.
No worries. Zach, do you know where it is?
Both of my things have problems. If I try to pin someone's screen to mine, it does theirs.
This one, the one on the left goes to that one, and the one on the right goes to the one on the right, I think.
That's correct. So, Mark, just take a look at my screen so I can show you
Well,
how
I
these
can't
match up.
for some reason.
Oh, you can't even see my screen.
When
Well,
I
that
try
makes-
to pin your screen to mine, it does my face 3 times.
That makes it tough. Can you see my whiteboard and me?
I can.
Okay, I'm just going to show you real quick this part.
Now you turned into Zachary. Or me. I don't know. You turned into me when you were presenting.
That's funny.
I'm confused.
No worries. So, Mark, if I have, for example, this equation,
I can't
Y
see
equals-
the equation.
y equals x minus 2 plus 3, y equals 1 over x minus 2 plus 3, right?
Oh, yeah, I see it.
So, did you catch what the asymptotes are? They gave us a graph. So if I were to graph y equals x minus 2 plus 3, the way that would look would be something like this. So remember how before y equals 1 over x never touched the x and y axes? It looked like this, but moved over here.
Mm-hmm.
So when I add in this minus 2 and plus 3, all it does is move the graph. And there's these things called asymptotes, which are lines that the graph approaches but never touches. In y equals 1 over x, the asymptotes are the axes, okay? So when I add in this minus 2 and plus 3, all they do is move the graph so it has new asymptotes instead of just the axes. And this plus 3 moves the graph 3 y units up. And this minus 2 actually moves it 2 in the positive direction. It's the opposite with this one. So this makes it so the asymptotes meet at the coordinate 2, 3, and otherwise it's the same graph, okay?
So which one is that? Is that the...
Oh, I just made one up because I didn't think you could see it on your screen.
Oh, I saw y is 1 over x minus 2 plus 3.
Yeah, so that's would look like this.
Yeah, still can't see. This is weird.
But that's all on Math Lab for the day. Those are rational functions. Pizza party.
I want pizza.
I want
Yeah, I could definitely use some pizza myself. All right, I'm going to let you guys go. That was our last Math Lab. Thanks for coming, guys.
Bye.